So for this video, we're going to prove the derivative of tan of x. So we know that the derivative of tan of x is going to be secant x squared. So how can we prove this then? Well, the first thing we could do is we could write tan of x as sine x over cosine x. So now we have sine of x divided by cosine x. So that means we have a function divided by another function, so we can use the quotient rule. So for the quotient rule, if we have some function, let's call it g, divided by another function, h, we're allowed to use the quotient rule then. So the g is going to be sine of x, and the h is going to be cosine of x. So we've identified what g and h are. So now we could use the formula for the quotient rule. So now we can use this formula to find the derivative of tan of x then. So we know our g is going to be equal to sine of x. So now we have to find g prime. So the derivative of sine of x is going to be cosine of x. So g prime is going to be cosine of x. And now the next term is going to be h. So we just have to multiply by the function h, which is cosine of x. So we have cosine of x times cosine of x. And now we're subtracting g times h prime. So we're going to subtract sine of x times the derivative of h, which is h prime. So we need to find the derivative of h, which is cosine of x. So the derivative of cosine of x is just going to be negative sine x. So we have negative sine x for h prime. And now we just have to divide by h squared. So h is cosine of x, so we'd have to divide by cosine x squared. And now what we can do is we could simplify the numerator a little bit here. So we have cosine x times cosine x, so it's just going to be cosine x squared for the first term here. And then we have minus sine x times negative sine x, so that's going to give us a plus sine x squared. And then we're just dividing by cosine x squared. So for the numerator, we have cosine x squared plus sine x squared. So there's a property with trigonometry that says sine x squared plus cosine x squared is equal to 1. So we'll use that property then. So we'll use that in the numerator here. So if sine x squared plus cosine x squared is equal to 1, that means cosine x squared plus sine x squared has to be 1. So we're going to get 1 in the numerator then. So now we have 1 divided by cosine x squared. So now we could also use another property of trigonometry that says the secant of x is going to be 1 over cosine of x. But here we have 1 over cosine x squared. So what we could do is we can look at this equation, secant x is equal to 1 over cosine x, and we could square both sides. So let's square the 1 over cosine x, and then we square secant x then. So if we do this, we just have secant x squared on the left-hand side. And then for the right-hand side, we have to square both the numerator and denominator. So we have to do 1 squared, which is just 1. And then we have to square cosine x, which is just going to be cosine x squared. So now we know that 1 over cosine x squared is equal to secant x squared. So that means the derivative here has to be secant x squared. So now we've proven that the derivative of tan x is equal to secant x squared using the quotient rule.